Hi, everyone. So today we're going to talk about doing an example of the first derivative test. So we're going to find the derivative, and we're going to figure out where the relative max and mins are for the equation 2x cubed plus 3x squared minus 12x. Okay. So given everything that we have been kind of doing, the first thing we need to do is we need to identify the critical values. And how do I do that? Well, the first step in that is to, good job, take the derivative. So, step 1, f prime of x equals 6x squared plus 6x minus 12. And then we take that answer and we set it equal to 0 and undefined to find critical values. I can factor a 6 out of this, which is going to make it a lot prettier. So x squared plus x minus 2 equals 0. Factor however you would like to factor, and you end up with x minus 1, not plus 1 must be, that was silly. Minus 1 and x plus 2, which get me critical values of 1 and negative 2. Okay. The next thing we're going to do is we're going to take those critical values and we're going to place them on our number line. Okay. Unlike with particle motion, though, our number line goes from negative infinity to infinity because we haven't been defined as anything else, whereas in particle motion, we were often defined as starting at 0 because that's when time started. Okay, so I'm going to put my critical values on here in numerical order, negative 2, and 1. And then I'm going to test my critical values. I'm going to test values on my intervals in my derivative. So I need a number less than negative 2. My choice is negative 3. So if I plug in negative 3, I get positive 6. And then negative 3 minus 1 is negative 4. And negative 3 plus 2 is also still negative 1. So I have a positive times a negative, which works out to be a positive. And because it's a positive, it's telling me that my function was increasing. Okay. Next up, I'm going to try a number between negative 2 and 1. I like the number 0, so I'm going to do 6 is positive. 0 minus 1 is negative. 0 plus 2 is positive. So I have a positive times a positive, and that's a negative, and that means that my function is decreasing. Let's actually tell you what values I tested here. So negative 3, 0, and let's go with 2, a number bigger than 1. So this is positive. 2 minus 1 is positive, and 2 plus 2 is positive. So I have a positive times a positive, which is a positive, which is increasing. Okay. So next up, we needed to test the values in the derivative, which we did. So I'm going to write down that step. I'm not going to write down that step. Now I'm going to write down that step. And we're going to use those values to figure out what is going on. Why does it keep doing that to me? It's just destined for me to use any color but black, apparently. We're going to identify the max and min. Relative max and the relative min. Okay. So the relative max, well, this changes from increasing to decreasing. So there's a relative max at x equals negative 2, and it changes from decreasing to increasing at 1. So there's a relative min at x equals 1. I'm going to have you work on your practice now, and we'll come back and we'll talk about that last step on Wednesday.